Alright guys, we're going to talk about the formulas that relate to gravity, force, and motion. The first of which is the distance, speed, and time formula. So you can see here that distance is equivalent to speed times time. Time is equivalent to distance divided by speed. Speed is equivalent to distance over time. Distance should be measured in meters. Time should be measured in seconds. Speed should be measured in meters per second. So you can use those SI units to measure each of these values. Now, that being said, you can also measure distance and time in other units as well. And you will be given some problems like that, which I'll show you in just a minute. The next formula that's important to be aware of is the gravity and free fall formula. That is delta V equals GT. You can also state that delta V divided by G is equivalent to T, and delta V divided by T is equivalent to G. Gravity is usually going to be 9.8 meters per second squared. The reason for that is that gravity is an acceleration formula. So gravity is acceleration. It is a natural property that objects have because of mass. It is created through mass. So make sure that you're able to use all of these formulas up here as well. And again, the delta symbol represents change. So this means change in velocity is equivalent to the gravitational acceleration times time. All right. And then the last one, force. Force is equivalent to mass times acceleration. We can also represent that in a triangle. So you can see that force divided by mass is acceleration. Force divided by acceleration is mass. And then these two multiplied together is equivalent to force. And going back to the acceleration again, this is very similar to what we saw with the gravity formula. So you have gravity times time is a change in velocity. Another way to express that is looking over here. You have the change in velocity over time is the acceleration. And here's the triangular format over here. Change in velocity divided by acceleration is time. Change in velocity divided by time is acceleration. These two multiplied together is delta V. Now this is the same formula as a gravity formula because here, acceleration, we replace that with a G for gravity. But gravity, in fact, is an acceleration. So a couple of things about acceleration. Usually the SI unit for representing that is going to be meters per second squared. But I could also say to you meters per minute per second, kilometers per hour per second, miles per hour per minute. I can express it however I want as long as I have two time units. That's the important thing, okay? So if I have two time units, that's an acceleration value. The first time unit goes along with the distance because that is your velocity. Kilometers per hour, meters per minute, miles per hour. The second is how long it takes to change that velocity. Alright, so looking at a sample problem. This is one that does not use the standard SI unit for acceleration. Let me adjust this real quick. Alright, an object is moving at 3 kilometers per hour. Its acceleration is 1 kilometer per hour per minute. How long will it take the object to accelerate to 6 kilometers per hour? So, if I write on the board, what I'm going to have is my current velocity is 3 kilometers per hour. That's my initial velocity. My final velocity is 6 kilometers per hour. I know that my acceleration, as it says up here, is 1 kilometer per hour per minute. How long will it take me to accelerate to 6 kilometers per hour? Well, since my second time unit right here is minutes, then I'm going to have some kind of answer down here in minutes. If I do the math, 6 minus 3, my acceleration, or the amount of change in velocity, is a positive 3 kilometers per hour. So, I can see here that 3 divided by something is 1. The only thing that makes sense there mathematically is the number 3. You want to make sure that everything matches up in terms of units. I have kilometers per hour in the minute, kilometers hour minute. So this is how you would solve a problem that would have a non-standard unit for acceleration and or velocity. Thank you. Do your best in your fever form.